And here we go, finishing up these last three problems using U substitution, integrating. Again, my inside function should usually be my u, so my inside function is x cubed plus 1. Derivative of that du is going to be 3x squared dx. And again, I can see that I have the x squared dx, so I need to solve this for x squared dx. So x squared dx is going to be 1/3 du if I divide both sides by 3. And now I'm going to go ahead and do just my straight substitution. I have the integral, and my u is x cubed plus 1, so I have the square root of u. And then my x squared dx I can replace with 1/3 du. Now in order to integrate this, I need to put this in terms of u to the 1/2 du. And now it's just going to be a straight integration. 1/2 plus 1 is 3/2. 1 over 3/2 is 2/3. U to the 3/2 plus c. Multiplying my fractions, I get 2/9. I'm going to go ahead and do my substitution back in, so I'm going to put x cubed plus 1 to the 3/2 plus c. Depending on what you're doing, you could possibly leave the answer like that. If you need more information or you need to be doing more algebraically to it, you could rewrite it as the square root of x cubed plus 1 cubed plus c. And this example. Again, my inside function is going to be the 3x squared. So my du, the derivative of this is 6x dx. Well, I have 3x dx, so I have 2 of these 3x dx's. So if I solve for 3x dx, it's going to be 1/2 du. And now I can do my substitution. I have the integral sine of u, and then my 3x dx I'm going to substitute with 1/2 du. The integral of the sine is the negative cosine, so this is going to be negative 1/2 cosine u plus c. And then finally my last step, just substituting that back in. So it's not actually a u, it's actually a 3x squared plus c. And the last one. Yes, we could look at the card, and on our integral card we have the integral of the tangent of dx. But let's just show how this comes about. So let's say you're in Calc 2 next year and you're not allowed to use that card, and you totally forget what the integral of the tangent of x is. You can come up with it, because the tangent of x is just sine over cosine. Now, which one of these should we have be our u? So let's think about this for a second. If I let my u be sine, the derivative of sine is cosine, but this is 1 over cosine that I have. The derivative of the sine isn't 1 over the cosine, so that tells me that I need my u to be the cosine of x. So du is negative sine of x dx. And again, I have the sine of x dx, so the sine of x dx is actually negative du. And now my substitution is going to be, my u is cosine of x, so I have 1 over u. And then my sine of x dx I'm going to replace with negative du. The integral of 1 over u is going to be the negative natural log of the absolute value of u plus c. And then using the substitution again, I have the negative log of the absolute value of the cosine of x plus c. And you can verify that by looking at your card. And many of those trig functions, the secant, the cosecant, and the cotangent are also, you can derive this way most of the time. If you have any questions, I will see you in class.